completing the square, the two things that I'm going to talk about today, completing the square and the quadratic formula, both of them work for every possible quadratic equation. And I'll kind of go through when I would use one over the other, but completing the square is very useful if you understand how to do it, because it can replace the quadratic formula oftentimes, and it allows you to work with much smaller numbers, especially if you're doing hand calculations like you guys are going to be doing on the final. All right. If you are working to complete the square, you follow these steps. First, you want to write your equation so that it's in standard form. Remember, standard form for a quadratic equation is ax squared plus bx plus c is equal to 0. Okay. Now, the first thing that you're going to do on this is look to see, can you use one of the other methods. The factoring and zero product rule method is the easiest. So if you can use that, do that first. If not, then you might want to consider completing the square. Okay, when you do this, if you can, try to get a leading coefficient of 1. Okay, so that's the ideal situation. So let's do that here in this problem. Is it possible to get a leading coefficient of 1? What do we have to do to every term? Yeah. Because we're dealing with an equation, if we divide every term in the entire equation by 2, the equation remains balanced. So it simplifies to x squared minus 4x minus 2 equals 0. And now you can look to see, are there binomial factors for this? Are there two factors of -2 whose sum is -4? No. If it's not, then what that tells you is you don't have rational zeros. That means if you have solutions here, they're going to have square roots in them. And that's where completing the square comes in handy. If you know you don't have rational zeros, I would suggest you use completing the square, or try it. And when you start to complete the square, and what you're going to do is you're going to isolate your constant. So even though I had you write it in standard form first, once you determine that you're going to complete the square, move the constant over to the other side. Notice I left a space here. I left a space because that's where I'm going to complete the square, which is your next step. And when you complete the square, you perform the following steps. You take half of your b value, b is your first degree terms coefficient, again right up here in the standard form. Okay, so half of b is -2 in this case. Then you're going to square that value. Okay, so we take half of -4, which is -2. We're going to square it, and then you're going to add that to both sides of your equation. Okay, so -2 squared is a +4. This step is always going to involve adding. It's never going to subtract anything from either side of the equation. You're always going to add the same value. Again, by adding the same value to both sides of an equation, you maintain the balance of that equation. And what completing the square allows you to do, this allows you to, you put the expression in the form of a perfect square trinomial. And perfect square trinomials are the polynomials that have that allow you to factor it into a binomial square. Okay, and so what that means is we can take this whole expression right here and rewrite it as a binomial square. And then we just use the rules. The x is our first term, half of the b value is our second term, and that is our binomial square form for that expression. Okay, and then just simplify the right side. Once you do all of that, you can finalize this by doing what we talked about yesterday in section 5.2, and that is extract the square root. Okay, so we have now one value that's squared, so we can use the method of extracting a square root. And when we do that, take into consideration the positive and negative root, simplify. In this case, the square root of 6 does not simplify any further. And then isolate our x by adding 2 to both sides. And so we get our solution, 2 plus or minus root 6. Okay, questions on completing the square? I want you to try it on your own here really quickly. If you look on page 42 at sample problem 6a, okay, I'll write it here for those of you who are just working on scratch paper. Again, a lot of you are more comfortable using quadratic formula for these types of problems. If you can become comfortable using completing the square, it's usually easier, okay, especially if you don't have access to a calculator. Because if you guys have access to your TID9s, should you be doing quadratic formula? No, what should you be using? Yeah, use a solve. Don't even waste time if you have your TIs. But completing the square is often a really efficient way to approach these. So let's say we take this problem. All right, so it's already written in standard form. Let's test it and see, can we factor this? Are there two factors of positive 13 whose sum is negative 8? No, so it's going to have irrational solutions. The zeros will be, the solutions will be irrational numbers. Okay, so let's isolate our constant. We move it over to the other side. And now let's complete the square. So we take half of our b value. Half of negative 8 is negative 4. Negative 4 squared is positive 16. You're always going to add the same value to both sides. And what that's going to do is allow you to rewrite this left side as a binomial square. The terms of this binomial are always x, and then whatever half of b is. So you get x and a minus 4. And then if you simplify the right side, you get your 3. And now you can extract the square root, leaving your base of x minus 4 is equal to, have to take into consideration the positive and negative root for that. And then just isolate your isolate your x by adding 4 to both sides. And so you get your solutions are 4 plus or minus root 3.